Can we get started? Yeah, so hi everyone. Welcome to the ZK Coprocessor panel. And we have very strong companies here to share their insights and their updates. So first of all, could you guys introduce yourself, your company, the product you guys are working on? Yeah, I will start with Ismael.
I'll kick it off. All right, I'll kick it off. So my name is Ismael. I'm the founder of Lagrange Labs. So we build infrastructure that makes it easy to verify large-scale computation on-chain that uses as input blockchain state. So you can think of a blockchain and a block header as a succinct commitment to the chronology of the chain. And what we enable you is to have very expressive applications with rich relationships with the underlying data in that chronology.
Hi, so I'm Kacper. I'm one of the co-founders of Herodotus. At Herodotus, we're focusing on building storage-proof technology that allows you to read arbitrary on-chain data, both current and historical. That's kind of where the name comes from. And yeah, so what you can do is storage proofs. You can read things like balances of your tokens, prove that you interacted with a given smart contract in the past, and build really powerful applications that have this cross-chain element and historical data access.
Hey everyone, my name's Manasi. I work at a company called Rezaizadeh. We've built a general-purpose zero-knowledge virtual machine. Essentially what that means is you can take any arbitrary piece of code and run it in a ZK environment such that it generates a ZK proof. And we've targeted the RISC-V ISA, which enables us to have developers write their applications or protocols in common programming languages, right? Rust, C++, and Go.
Hey, I'm Yi. I'm one of the co-founders of Axiom. We allow smart contracts on Ethereum and soon rollups to access any piece of data that's appeared in the history of Ethereum and do ZK verified compute over it.
Yeah, thanks for the introduction. So I will start with the first questions today. When more and more people recently discussing about a ZK coprocessor, I'm thinking about a very important company history of NVIDIA, which is the best bet on CUDA. I think after CUDA, the GPU, the functionality switched from purely image processing to more generalized computing. And back to the blockchain space, over the past few years, we have accumulated many more on-chain data and also user behavior on-chain. And in your opinion, how do you envision the future landscape of blockchain or application on blockchain with the support of ZK coprocessor? And what do you think the stage we are now? Yeah.
Yeah, I think there is an inarguably large amount of data that can be proven with respect to a current block header on most major blockchains. The state with which blockchains update and the speed with which they update, most people don't really appreciate, and the amount of transactions that are encoded in that chronology is something that most application layer developers can't reasonably compute over. So I think with ZK coprocessing in the context of transaction data, you can really build applications that have the capacity to ingest and prove the result of some synthesis analysis on top of a far larger set of inputs than they can directly in the execution environments now. In terms of the stage we're at, I think we're at a stage where there's early applications, like a lot of the folks on stage here, that are starting to allow application-level developers to touch and access this data. Though over time, I think we're going to have to see the proving systems that people use, both at the back-end proving level as well as the hardware level, continually innovate and push the state of the art. Otherwise, we're not going to be able to have applications that can reasonably access any amount of chronology that they may want.
Cool. So I like to think about blockchains in a way like the early days of computers. In the very early days of computers, we had circuit boards that essentially contained everything on a single piece of hardware. And over time, as different applications were built on top of those circuit boards, different manufacturers started specializing in different areas. So you had hard drives come around, you had companies that started building those actual processors that do the compute, and the companies that put it all together, kind of like the motherboards. And I think this applies a lot to like layer 2s, but it also relates to where like ZK coprocessors come in. A lot of this like compute will need to be offloaded somewhere sooner or later. And I think right now we're reaching a point where the types of applications that people want to build on blockchains are getting way more sophisticated, and ZK coprocessors can take on that excess demand for the resources that are necessary on the blockchains.
Yeah, I think we've seen the evolution of crypto and blockchain technology over the years, especially during the Rust bull market. We saw the pains in terms of the infrastructure bottlenecks that we had, and in a way, the bear market has been helpful, where we've been able to be super heads down, building the infrastructure in the hopes of the next cycle, where we are now ready for more complex applications, more data-rich applications, more just diverse set of functionalities that already exist in the Web 2 space, but in the Web 3 space, most applications in the last cycle were pretty limited in what they were capable of. And so I think, in this future world where ZK exists, even in the ZK coprocessor model or as ZK rollup model, we definitely would see, and that's the hope, that we would see a lot more user-facing complex applications that are real-world use cases. In terms of stage, I think Ismael already mentioned, we are definitely in the early adoption stage where we are experimenting, even with the idea of ZK coprocessor and what it can enable. And really, I think we have some ideas as builders in this space in terms of what this technology can do, but we are just scratching the surface.
Yeah, I would say I generally agree with all the sentiments expressed so far. Maybe one point to add is, I think so far it's been very difficult for most developers, even those already interested in crypto, to understand the capabilities of ZK and really tap into them. And I think one thing that might change us from early adoption to broader adoption is making it easier for your average developer to actually understand how to work with ZK, how it's different from a traditional Solidity programming model, and what it can do for them.
Awesome. And you guys all mentioned some limitations of Ethereum just now. And we know Ethereum has enabled permissionless decentralized computation on chain with smart contract, but we all know smart contract has very limited access to the on-chain data. And on-chain data is growing, making storage or processing super complicated. And fetching off-chain data requires trusted oracle, which can bring some centralized risk or a single point of failure. And privacy is still limited for sensitive computation and data. Certain computations like machine learning are too complex to run on-chain. However, thanks to ZK, we have a way to overcome these limitations in a fully trustless and decentralized way. And what inspired you to build a ZK coprocessor for Ethereum, and what problems does it solve that were previously difficult or impossible on Ethereum?
Yeah, so what inspired me really is I was a Solidity developer for a time prior to founding Lagrange, and I frequently found myself bumping into limitations of what I could do in the execution environment. I had to find myself relying on less secure and centralized off-chain ways to populate my application with the data that I needed. I needed off-chain price feeds, I had to rely on K of N bridges, and it didn't really feel like my application could inherit the safety of the chain that it operated on. So I wanted to build something that allowed applications and application developers to really be able to have these trustless applications that are truly as safe as the blockchains they're on. And that required, for us, to build infrastructure that let application developers have more expressive access to the data encoded in the chains that they build on.
So the inspiration for Herodotus is really in the name itself. Herodotus was a historian, and from the very beginning, our focus was really on this historical data access portion of the space. And I think that area hasn't been explored much, simply due to that limitation just existing inherently within Ethereum. And only now we're starting to, like, personally at least, hear a lot of different projects that are coming up with ideas we didn't even consider before for historical data. And doing the actual compute on top of it was something that came to us a little bit later. We realized, okay, now that we have these historical data feeds, we can do compute over it. So you can do things like TWAPs over and volume-weighted average prices over different types of like on-chain price fees and similar.
So our story at Rezaizadeh is a little different. We didn't really start off as a ZK coprocessor project. Like I mentioned, we had a general purpose ZK virtual machine, which means we can enable ZK coprocessor as one of the use cases. Of course, we are also focused on just enabling ZK rollups, enabling other ZK applications. But specific to ZK coprocessor, I think of it as 3 categories. So one category is, what my fellow panelists mentioned, is accessing historical on-chain data in a trustless manner and doing analytics and heavy computation on it, which wasn't possible before. The second category is increasing smart contract complexity. So a good way to think about it is maybe an example where it's really difficult to do on-chain order books. It's very extremely cost prohibitive. Solidity is not really meant for complex on-chain computation. And so you can think of offloading these complex computations to a ZK coprocessor, where it handles the order matching logic in this example, and then generates the proof of that matching logic such that you don't have to trust this off-chain computation and use that proof for settlement on-chain. So that's the second kind of bucket, which is expanding what's possible on Ethereum L1 without having to move to L2. And then the third is not only accessing on-chain historical data, but you can access now off-chain data. Say you want to access KYC or identity information from a trusted identity provider like ID.me, which is a big provider in the US. Before, you have to rely on trusted proxy services or intermediate services that translate that over onto on-chain access. And now with ZK, you can take that information, run a ZK proof that you got that information from a trusted provider, and submit that proof on-chain. So now you're bridging off-chain data sources as well on-chain. So that's how I think about ZK coprocessors.
Yeah, much like Ismael, actually, we came to this idea from a concrete problem we faced as Solidity developers. Specifically, I was helping a friend out with a on-chain insurance protocol. To settle insurance, you really need to know whether some on-chain guarantee was or was not violated in the past, and we came to the conclusion that there's no really trustless way to accomplish this. Similar to actually Herodotus, the insight that computation was relevant really came afterwards. We talked with a bunch of developers, and they kept asking us for various types of computations. And they actually kept surprising us with how wacky the computations were. And so we came to view the compute side as perhaps equally important as the data side as time went on. And so broadly speaking, we're always pretty driven by developers who want to push the envelope of what's possible in an on-chain application. I think rollups have done a great job scaling Ethereum, but they broadly allow smart contracts to do more of what you can do on ETH-L1. And I think the promise of co-processing is to allow fundamentally different types of applications with different types of compute and data access.
Yeah, and I think just to add, I think that ETH L1 component is super critical, right? With L2s, definitely you can scale your application, but you have to now worry about bridging your asset, moving things between L1, L2, data availability. With ZK coprocessors, you are essentially scaling at the L1 level.
Yeah. We mentioned application just now, and if we go back to today's topic, applications, I think ZK coprocessor enables the blockchain to outsource the data incentive computation and retrieve the result back on smart contract quickly at low cost. And thanks to ZK, we don't have to introduce any other additional trust assumptions. And with this magical technology, developers can empower their apps to be data-driven. For example, we can see many exciting use cases in DeFi, NFT, gaming. And moving forward, which application space has the most exciting developments or potential over the next 2 years with ZK Coprocessor?
Yeah, that's a very good question. So one of the things I'd like to say is that for all of us to be in crypto, we have to believe that there will be more consumption of block space. Because if there's not more of a consumption of block space, there's really not a point for us all to be in this industry. So there has to be something that's going to be leveraging the infrastructure that all of us are mostly building in order to be able to deliver some meaningful value to some new group of end users. And so I think there's a lot of very exciting work being done with building new DeFi primitives, building new social-fi or GameFi experiences on chain. And as a team and a company, we're very agnostic to what the requirements are for those developers. We just want to make sure that the infrastructure we build best serves them. And so what I also think is the corollary of there being more of a consumption of on-chain block space is that there will be more data generated, such that the problems that our team and many of the teams on stage are tackling right now will become increasingly prevalent. And so the corollary of the block space being filled is really the need for everyone here to ensure that their applications or their infrastructure they build can sufficiently handle that increased volume and demand.
Yeah, I think the use cases are very broad, but I think the ones that particularly will benefit off of ZK coprocessors are the applications that require huge amounts of data. So an example of that is like ZK ML. Imagine right now trying to feed a ton of those public inputs on chain, very expensive, and in many say, I would probably say that it would probably be not commercially feasible. With ZK coprocessors, we are able to offload that off-chain and simply just verify that this computation was done correctly. Yeah.
Yeah, and I think on top of that, the ZK component adds the privacy factor to, just if you were running an inference off-chain and you don't want to reveal your model, but you still want to, release these results that are trusted by other parties, and I think that's the other kind of value proposition of ZK. But in terms of use cases, yeah, I think, there's definitely ZK touches a lot, but we are seeing a lot of movement in the DeFi space where really if you're competing with, traditional finance and want to build complex financial applications, you're pretty limited by what you can do in Solidity and the current gas models. And so just to build, even like a Black-Scholes options pricing model, which is pretty standard in the TradFi world, it's really impossible to do that or cost prohibitive to do that on chain. And so now with ZK coprocessors, you can really build these complex synthetic financial products. So DeFi, the other use case I already mentioned is in the identity and KYC space, being able to bridge the Web 2, Web 3 world is super exciting. And then I think someone mentioned gaming. I think gaming is another sector that needs a lot of computation and also low latency computation, so that's critical.
Yeah, I think in addition to, obviously we agree with the applications all the other panelists mentioned, I think one aspect is that ZK coprocessing allows applications on chain to make asynchronous calls, and I think that really changes the dimension of what's possible. The second thing is that it allows applications to really compose in a much more modular way. So today, if you want to compose with an application that you didn't write yourself on chain, you kind of hope that that developer put enough data in state for you to be able to do your composed technique. But very frequently, that's not the case. And what ZK allows you to do is actually read arbitrary data from the execution of that application and use it however you like. I think this is particularly interesting in gaming. I think the whole story of on-chain gaming is that there's supposed to be a composition between different games and thus greater meaning to the items in the games. And I think ZK is a way to fundamentally weaponize that.
Yeah. In IOSG, we have some internal discussions about the use cases of ZK coprocessor. The first one is, imagine in a centralized exchanges like Binance, they have loyalty program. Like you trade more, the commission will be less in the future. And if you hold the token, the commission will be lower as well. And the second use case is like, imagine a game, like interactive game. They can give you some suggestions based on your each click back and forth and guide you how to play the games. And this could be definitely possible with ZK processor for fully on-chain gaming, for DEX. Could you guys share one example or use case that you would like to share with all the audiences, like using ZK coprocessor?
Yeah, I'd like to share a very simple one. You have an NFT contract which has an index which corresponds to the NFT's number. It has the mapping, the second index, the second value would be the owner, and then you have some associated metadata. And let's say this is a cat NFT, and the metadata, of course, the third property in the mapping corresponds to the color of the cat. And you want to, from another contract, search for all the users who own blue cat NFTs. If this was a database and you were building this with SQL, that would be trivial. It would be a select statement. You'd learn this in CS 101. With Solidity, you would have to loop and iterate through every index of that mapping in your contract in order to check whether or not a cat was blue. And this is a very inefficient paradigm to allow one contract to query the data of another contract. And as everything in chain is stored in mappings, mostly for ERC-20s and ERC-721 contracts, it is really inaccessible at the point of execution to most contracts, both external contracts and contracts themselves being able to access their own memory. So I think as we start thinking about building applications that have richer data access just to themselves, you can actually start unlocking a lot of things by just being able to query over your own state.
One application that I'm particularly very excited about is in the DeFi space. So essentially being able to do loans that have variable interest rates that are based on your prior performance, your prior history of actually repaying these loans, or even tying them to your social reputation on social reputation platforms. Currently, that's not an area I think that was explored at all. But I think it will be interesting to see how the performance of how protocols actually design and use historical data to build such kind of financial products.
Yeah, I already gave a couple examples, but I'll maybe talk about this showcase that we launched a couple days ago called Bonsai Pay. It's essentially, it's a very simple use of ZK coprocessor. It essentially allows you to send crypto to a Gmail account. And what it does behind the hood is this OIDC standard, which is an identity standard that most identity providers like Gmail, Apple, PayPal, you name it, they provide these JWT or JOT tokens. And what Bonsai does is processes that, ensures that you have access to that account, you are the true owner of that account, and then connects that to your wallet. So instead of remembering someone else's wallet address and having to send payments that way, you can just send payments to a Gmail account.
So in the spirit of the theme of the event, I think in GameFi and social applications, actually the role of ZK coprocessors, I think it's pretty different from other perhaps higher stakes applications. In DeFi, you really need the trust guarantee to not have users lose money. I think arguably in an on-chain game or an on-chain social app, you don't really care. But I think it can offer to developers a way to outsource various operations that they would otherwise have to spin up kind of a server to run. And it actually offers a way for them to delegate certain types of computations that otherwise they'd have to be a centralized operator for. One example could be, hey, you can only mint an NFT if I've transferred Ethereum to you before. You can imagine various types of kind of silly viral mechanics like this. And I think it just gives developers a greater tool set to actually work with. Yeah.
I also wanted to add one more thing. I think we've already seen in the last cycle very strong prior art that developers are interested in these types of applications. We've just seen them embodied in ways that have cut corners on security. We've seen more and more GameFi and SocialFi applications towards the end of the cycle having less and less of their components on-chain. I think what everyone here in this panel is working towards is to allow these applications that already exist and have already tried to push the boundaries to now be able to do that in a more secure way.
Zero knowledge proof is probably the most complicated concept we have seen in crypto. And making ZK accessible and easy to use for developers is difficult given its complexity. For example, if I'm a gaming developer, I'm an NFT developer, I want to use ZK Coprocessor, but I have no idea about the underlying logic, I have no idea about the circuit. So in your past experience, what are some of the biggest technical challenges and trade-off in different types of use cases when you guys were touch base with your customers, and how did you overcome these challenges?
Yeah, so I think one of the difficulties on any technical subject is trying to ensure that your customer base or your user base understands enough of it to be able to apply it to their problem set that you may not be an expert in, but doesn't become burdened by the details of it that are superfluous to them. And I think a very good developer tool set, it enables the developer to appreciate the complexity that underpins it without requiring them to become an expert themselves in it. And so when we are engaging typically with our customer base, it's really about allowing them to understand in practice what they can unlock through using this toolkit without requiring them to understand all of the underpinnings of how ZK works, proving systems work, constraint systems work. And this is why I think we're seeing a shift in ZK away from, I would say, proving system-centric companies into companies that are more proving system agnostic, but offer a unified experience exposed by a set of APIs or a set of on-chain contracts.
Yeah, I think I would say that most of the complex use cases that would want to integrate with ZK coprocessors would require they would require you to do compute that is specific to their individual needs. So generalizing the kinds of compute that we would be offering or the clients would require, in many cases, is very hard to predict until you actually speak to those clients. So abstracting away the circuits, the ZK behind interfaces, like at Herodotus, we're doing an interface called Turbo. It's a smart contract interface that allows you to communicate with an off-chain API and really using ZK coprocessors as easy and simple as possible is very necessary to be able to benefit off of the economies of scale, as well as driving down the costs of this off-chain compute if you can mutualize it amongst many users.
Yeah, I think you guys already touched on this, but traditionally, if you were to build with ZK, you would have to understand how to write a ZK circuit, the underlying cryptography, and that's a huge learning curve. Some people are interested in it, some people are not. And I think, it's really critical as an industry for us to build these abstraction layers and tools so that the time to market for developers is shortened. It doesn't, if you're spending 6 months just learning about ZK and then another 6 months thinking about your problem and trying to build it, that's really not the best developer experience. So in our case, that's how the company started. We really wanted to make ZK accessible in a manner that, developers don't have to worry about the underlying cryptography. They don't have to think about circuits. We handle all of that with this general purpose ZK VM and enable developers to write code like they usually do in Rust, C++, Go, languages that they're familiar with. What this also enables is, you're not learning a new DSL or a new language, and you can tap into existing libraries, existing cargo crates, such that you don't have to build everything from the ground up, and you can leverage existing tooling that exists in, the Rust ecosystem, for example. So I would say, yeah, I think that's kind of our approach, reducing, any kind of friction for developers and just making it as simple as possible for them to build.
Yeah, I think I probably agree. Solidity developers probably do not want to learn how to write ZK circuits. I think maybe less than 1% of them do. What I do think is important is that they understand the properties of ZK that they're applying. I think it's very easy for a developer, even if they're not writing a circuit, using a general framework to misuse it and think they're getting a guarantee that they're not, or think that they need some guarantee that they don't. And so broadly, we try to communicate the properties of the system while requiring developers to know as little as possible about the internals.
Maybe I could add on to that a little bit. I think that like when you start thinking about a blockchain as a database where you can actually query data, it's kind of like when you look at like SQL or like a Postgres, you can access data and then do compute on top of it. And that's something that's built directly into the database. However, like right now we kind of like added an additional table for, let's say, time. And you are able to still do that compute over that new column that was added.
To add one more thing, I agree with everyone on the panel. I just want to add that I think it's very dangerous if, as an industry, we set the abstractions too high and we try to start building ZK systems that remove the user's understanding of what ZK is and what trustlessness is. I think this is how you start having an industry that has players who are less than honest about the security guarantees of their underlying products, since the users are no longer exposed to the crucial decisions that they should be considering when deciding which player to go with. And obviously everyone here is a very reputable company, but there are other players in the space that I'm sure will continue to emerge that may not take as principled an approach to the application of zero knowledge, honestly, to a problem set that they tackle.
Any other opinions?
Yeah, maybe one thing to say is, I think actually the best way to defend against this is to have an industry-wide standard of a lot of transparency in what's actually happening. Although most users are not going to look and don't want to look, I think the 1% of users who do a great community service for everyone else by policing any sort of bad behavior.
Yeah, and I think the education can also happen at the design level in terms of how to think about security when you build with ZK, how to think about just designing your use case and applications, what are the optimizations that go in. So yeah, I agree that we can't abstract everything away, but there are layers at which we can educate people.
Which aspects do you think that can lower this barrier? For example, like developer documents and user education and better social media promotion of ZK processor? Which do you think is the most important one?
I think like being upfront about trade-offs. Like every single application that you want to integrate with has trade-offs. Some of them can be like, in our case, latency versus cost. But if you're upfront about trade-offs, including the downsides, I think that's where it's at.
There is an inevitable dimension of education, and that is time. And I believe that we are very early in the life cycle of ZK and crypto. And I think as we start seeing time pass, as applications continue to launch that leverage ZK, the early movers, the first adopters, and it starts becoming a more commonplace property within mainstream applications that we see on chain, I think more and more developers will become aware of it. There's obviously things we can actively do to accelerate that process, having better documentation, having more intuitive ways to either write a constraint or to define your computation. But I think inevitably the slow advance of ZK in crypto is something that we're going to continue to see.
Yeah, I mean, beyond what everyone has already said, I think another way of bridging the gap is building showcases and building demos yourself. Because you are definitely the most familiar with your technology, just showing what's possible or just early ideas of what's possible with your technology and using that as inspiration for developers.
Yeah, totally agree with that. I think you can educate all you want, but ultimately a single example is probably worth a million tutorials.
If we go back to the tech itself, like while ZK enables a lot of trustless computations, the technology itself still has some key constraints. For example, proof generation requires very heavy computation, limiting the performance. Trade-off exists between proof size, verification costs, and computational constraints. And thanks to like a very efficient prover market design and those ZK acceleration companies, I think it can be like hyperscale in the future. And at this stage, what problems remain unsolved before more complex real-world use cases become viable? What improvements of ZK need to happen for it to scale even more complex use cases?
I can go. So I think saying that there's a problem that needs to be solved is not the same framing that we typically look at it with. We think that there is a need to iteratively and continually push the state of the art in the core primitives that our team builds with. This is why, as a company, we've taken a very research-centric first approach. Thanks to some tremendous folks on our team like Babis Papamanthu, Shravan Srinivasan, Nicola Guiley, we have really been able to take the state of the art once we kind of enter this space tackling this problem set and ideally advance it such that the performance of the systems that we can now operate with are an order of magnitude faster for the things that we need them to be. And I think that teams that do this and teams that kind of take that research and state-of-the-art research innovation first approach are those that really long-term have the capacity to most push the state of the art.
I would say that interfaces that abstract away the areas where things can go wrong. I think it's not a wise thought to expect like auditability of circuits, for example. It's a very challenging thing. I think the tooling that's being built and developed to make working with circuits easier has been phenomenal and is improving consistently. But that's an area where a lot of things can go wrong if you don't have the know-how. And for ZK coprocessors to be used at scale, those elements of they're being used for like efficiency reasons, which makes a lot of sense. But since a lot of things can go wrong in that area, abstracting it away as far away from the end developer, I think will make using ZK coprocessors more secure.
Yeah, I think there's no denying that performance, is definitely an area where we need a ton of improvement when it comes to ZK. But it has come a long way. Just to give an example, a year ago, to prove an entire Ethereum block, like just doing a type, 1 ZK VM to prove a single Ethereum block took multiple hours. And now we are, at this place where proving a single Ethereum block takes less than 20 minutes. So we've made significant progress in terms of performance, but it's not, in under seconds, which is ideally where we would love to be. So, in the meantime, there are trade-offs where you could build a hybrid approach where you could do execution in an optimistic manner. The ZK proofs can be delayed and lagged, and you wait till that happens for finality. But I'm very optimistic. I think a lot of people are focused on figuring out better performance, better ways of improving performance, optimizations, new proof systems are coming our way. So I would say that's probably the biggest area that we need to focus on.
Yeah, I think the situation with regards to performance is what it must have been like to run a semiconductor company in the early 80s or late 70s. You really have to be continually assessing new state-of-the-art proof techniques, thinking about how far away they are from production, and also picking and choosing your spots on which advances to commit engineering to and which advances to leapfrog. I think all of us probably expect significant improvements even over the state of the art today. And it's really all about making sure you have a robust and actually secure production system that you're taking to offer products while still making sure you're future-proof in both your design and your research work.
I think we are running out of time, so one last question. Looking forward, you guys are already pushing towards a super exciting future with ZK coprocessor. At the end of this panel, please feel free to share the latest product update, your roadmap, milestones in the coming few years with all the audiences.
So I think on this panel, we've talked about data in the abstract a number of times, but I think it's important to conceptualize that really the ability of a coprocessor to deliver meaningful computation over data is constrained by the amount of data that that computation can actually run over. And I think people typically now just hear the word coprocessor and they immediately assume that there's equivalent computation and data access that they all can really achieve and they can all leverage. So with what we do at Lagrange, the priority that we really have is how do we maximize the amount of underlying storage, state, and receipt data that we can compute over within a given proof in a short enough period of time to be reasonable for the applications that we integrate with. And so there's some great work that our team has done on this at SPC over the summer. We released a paper called Rec Proofs that presents some very interesting properties in new construction that's very performant for large data, up to 135 times faster than anything before it. And our team will be releasing towards early next year a test net with this new construction and some interesting new work our team has done as well to really enable kind of coprocessor level computation to finally hit a big data scale.
At Herodotus, I encourage developers to go check out our API. You can register on the website, get an API key, make queries for storage proofs for arbitrary on-chain data. Currently, we support Starknet, Ethereum, and Optimism. And in the future, for us to roadmap for the coming months, near the end of the year, we're going to have a working prototype for Herodotus Turbo, which essentially is a smart contract interface that allows you to interact with this API fully on-chain without having to deal with API keys or understanding the whole workflow that has to happen behind the scenes.
Yeah, for the Zero product update, I would say we have Bonsai, which is built on this general purpose ZK VM. Bonsai is our ZK application development suite, so developers can offload all of this computation in the ZK coprocessor manner. We recently open sourced our high-speed recursion and then start to snark conversion, so you can really take the large start proofs, convert them to really small snark proofs that you can then use on-chain. And what's coming up next is proof composition, which we are very excited about. Essentially, they'll enable you to take multiple proofs and compose them into a single proof so that you can amortize cost.
Yeah, so we launched our first version to mainnet this July. It allows you to query in a fully on-chain way up to 64 pieces of historic block header, account, or storage data. In the next couple of months, we're looking to dramatically expand that and also allow developers to access any piece of historic data that's ever appeared on Ethereum.
Yeah, thank you. Awesome. I think this is the end of this panel, and thank you all for your excellent insights.
Thank you for having us.